called as a glass slab. Yesterday I was studying about this. It is in the form of rectangle, or you can say it is a cuboid form. Okay. So what we have to do, we have to just keep this glass slab on a plain sheet, and then just we have to draw the border or perimeter of this glass slab. So what we'll do, we'll draw the border. Okay, then I will remove this, and then we have to give the name for the corners, that is A, and then B, C and D. Okay. Now I require one protractor also. Get the protractor if you have. Okay. So now I have to draw a normal for this. Okay, one line normal I have to draw. So anywhere you can take a normal. Normal, you know, it should be a perpendicular line to the sleeping line. So I will draw first one normal. So this is our normal, fine. Okay, give the protractor. Now this protractor I have to keep exactly on the normal and on the sleeping line. See here, I have kept. See, this shouldn't be disturbed. This side, this black color line should be on the sleeping line, and the straight line also should be on the normal. So I have kept like this way, and then we have to take the angle. So this is 90. Now this I will consider as one small divisions including one this. So this will be a 10, 20, 30, 40, like that way I will take, because I have to take the incident ray. So I will take 40 degree angle. So from 90 to 80, 10, 80 to 70, 20, 70 to 60, 30, 60 to 50, 40. So I will take the incident angle of 40 degree. Okay. So from here you have to draw the angle. That is how much we have taken incident angle? 40 degree. So I have drawn this. You have to show the arrow mark, and this is your incident angle I. And this is how much? 40 degree. So we have taken I is equals to 40 degree. Okay. Now next, what we have to do, we have to keep this glass slab as it is, because we have to find out refraction. So how the refraction, we know that. So this is air medium and this is glass medium. Okay. So now I will keep this glass again on the same place, and now we have to take these two pins. Okay. And then I'll insert here to see that whether the light travels in a straight line or no. And one more pin I'll insert here. Okay. Now what we have to see from this surface, from this face, we have to see whether, now if I'll see, this will be the straight line, correct? If I'll see like this way, but I have to see through the next medium, that is a glass medium. So when I'll see through the glass medium, I have to see this surface, not there. So I have to see here, and I have to see whether it is in a straight line, and I have to insert this pins in a straight line. Okay, so I will see, one eye I will close, and I have to insert this pin where it should be in a straight line. I will insert the pin. Come and observe from me. It should be in the straight line. Come and see from one line. Can you see that? See here. See here. All four are in a straight line?
Yes,
correct? One eye you have to close and you have to check. All four are in a straight line. See this. Come. See here. All four should be in a straight line. Next, boys. Come. Check whether they all are in straight line or no. Next. All are in straight line. See the pins. Don't say just yes. All are in four straight lines. Okay, now what I will do, I will remove this glass slab now. I'll remove this glass slab and I'll remove this pin also. I'll just mark it. Then I have to draw the line. I have to draw the line. And from where, here also we have to draw a normal. Okay, and then I have to join this and this. So this will be your, this is I, incident ray. This is what? Your refracted ray R1. And this is what? R2, which is emergent ray. It is R2 is equal to emergent ray. And this is called as interface or boundary. You can write it as O. This is also interface. This is write it as O. So this is a rarer medium. Why it is rarer medium? Why it is rarer medium? Air. Medium is air. This is
glass.
Denser medium. So this is glass. Then again this is rarer medium. And this is air. So you can see this is 40 degree. Then we have to check what is the degree of this R1. It should be, according to the yesterday's lecture, R1 should be greater than I or smaller than I?
Small.
Yesterday you studied, no? Greater than R or smaller than R? I should be more than R, that is refracted ray. So now you can see here, this is 10 and this is another 10, means this is 20 degree. You got R1, how much? 20 degree, which is refracted ray. And now again you have to check this also. 10, 20, 30, 40. We got 40. Somewhere minute error will be there. So this we got 40 degree. So E we got, that is R2 we got 40 degree. So yesterday what we have studied? What you have studied? Incident ray and emergent ray should be equal. When the incident ray strikes on the boundary, that angle, and when the refracted ray strikes on O dash, we get the emergent ray, that angle should be always equal. So we got both 40 degree, 40 degree. So you can see that when the light is traveling from rarer to denser, it is moved towards the normal. So this line is refracted ray and this one is imaginary line. It should be, we should get it straight line like this way, but when we have seen through the glass slab, we saw that these two pins were looking like they are here. This is due to the refraction. Now you can see from light is traveling from denser to rarer medium. So it is moving towards the normal or away from the normal? It is, this line is moving towards the normal or away from the normal? Away from the normal. Because it is a rarer medium. In rarer medium, light travels faster. In a denser medium, light travels little slow. So clear about this experiment, and this, you can see these both are parallel lines, and you have to see this distance between this both is called as a lateral surface. What it is called as? Lateral surface. This is called as L. This is lateral surface. So what is L we got now? We have to take this also. L is around 2.2 centimeter. What we got L? L is equals to 2.2 centimeter. So this is regarding glass slab experiment. We have seen that how the refracted ray angle we will get and what will be the incident ray and emergent ray. So this is incident ray, this is refracted ray, this is emergent ray, and the distance between these two lines, that is incident imaginary line and then emergent imaginary line, the distance between them is how much? 2.2, that is called as a lateral surface. Clear about this experiment?
Yes, sir.
Any doubt?
No,